Hi, Nicholas. My name is Ryan Lady. I lead the team running the charge for the systems engineering here. We put together this demo of the world's first quad-port SSD that is unique to not just automotive and industrial, but actually in all segments. So,
would you say quad-core SSD?
Quad-port.
Quad-port.
Yes. So,
what does that mean?
Good question. What that means is that it can interface with any combination of 1, 2, 3, or 4 different chips here, SoCs, and share or uniquely separate the data that's in that SSD. So it's what you're looking at here is just a passive board that breaks out those 4 ports through a cable to each of these NVIDIA SoCs. So all 4 of them are interfacing with one SSD that's here on this. It's mounted to this M.2 card, but it's a BGA SSD all in one. So it's uniquely fitting for the industry, that we're targeting, which is automotive, industrial, and in some cases, some high-end consumer.
Is it memory sharing?
It is. Yeah, it's storage sharing is what we're working with here. So let me show you this. This system here is on its own private namespace. So this is interfacing again with the SSD, but it's separated. Okay, and what we have here is this camera is recording video files here, one at a time, one at a time, one at a time. It's capturing those here. And then over here on this system, it's going to the same shared namespace, pulling that same video data back out after it's done recording. And then you can see, after it's done recording, it pulls it back out and replays it over here on this screen. So what we've done is put together a read and write heavy workload across all of these machines, so we can kind of display the horsepower that we've got with the SSD. So we're here playing a loop of recorded video. So this is reading from a private namespace, writing to a shared namespace, reading from its own private namespace, reading from the same shared namespace. So trying to do a lot of heavy mixed workloads here.
So each of these screens have their own processors running stuff?
Yeah, so each of these is just a NVIDIA Orin Jetson system. So each of these has their own unique processor.
Is it quite a powerful ARM processor running each their own Linux or whatever?
Correct. It's a high-end ARM processing system on a chip that is used in industrial and automotive applications. So
and they
very
do
common in
memory
ADAS applications,
sharing.
for instance.
Because normally you put when you buy a box like this, you buy an SSD inside or something.
Correct.
And then now you're showing that you could just have a bunch of them share one.
Correct, up to 4 of them.
And is it also possible to combine more SSD to make it faster, or is that a different thing?
Sure. It's with one SoC, you mean?
I don't know. You can plug more of these in there, and because there's a lot of bandwidth could be here potentially.
Yeah. So each of these is a PCIe Gen 4x1 interface. So if you needed more bandwidth, then you would just share fewer of the ports. Share combined ports, so you can get a PCIe Gen 4x2 or by 4. So it's a standard SSD that is fracturable into more than the usual one port.
What could be the market, you think?
So what we see very much is in the automotive market, we see a consolidation of the different domains. So what we've seen, maybe you think about like your ADAS domain, your IVI domain in a traditional terminology, working itself into digital cockpit domain. So we're seeing all these kind of converge into fewer controllers into a smaller space. So we're seeing that as we go, though, there's a very mixed requirement for different densities, different performance levels. And so in addition, there's the ability to share that data. So if you think about maybe HD maps, which is downloaded kind of on the fly for a given region for use in both ADAS and maybe in your digital cockpit for displaying your route, all those can be shared at this, with this kind of a setup with this system.
One of the new trends, some car companies are talking about 48 volt and try to simplify, save on cables. I guess they need to also be smart how they distribute the storage with all these cameras, the self-driving, and that's part of the solution?
Yes, exactly. So as the domains consolidate into a smaller physical space and into fewer SoCs, that's very much in line with what you're talking about there.
Is there other applications in the embedded world?
Of course. So if you think about industrial automation, there's definitely a very mixed requirement again for different storage devices. Maybe you have a very small storage requirement on one part of the system and a very high storage requirement on another. You can use the same storage solution between the two, cut down the total number of devices, and maybe reduce some cabling as well.